This
sir.
conference will now be recorded.
Yeah.
Your
So,
voice is not.
yeah, I'm Dr. P. Sri. Is it okay, sir? Now, hello.
Now
Yes,
it's
sir. It
okay,
is
sir.
okay. Okay. Go ahead, sir.
Yeah, sir.
It's
Now,
okay.
yeah, sir. Sir, yeah, I'm Dr. P. Sri, coordinator of this. So, coordinator of this FDP on alternate fuels. So, thank you for joining. Now we are going to start the first session that will be taken by Madam. We'll be dealing with the alternate fuels. That is the first session, and that will be till 1:30. And after that there will be a break. 2 o'clock. There will be a break from 1:30 to 2 o'clock. So 2 o'clock session will be from 4 to 5:30. That is the today's schedule. So, and I would like to introduce Dr. S.L. Sinha Madam. I would like to introduce Dr. S.L. Sinha Madam. So, she is currently a professor at the Department of Mechanical Engineering at National Institute of Technology, Raipur, in Chhattisgarh. She obtained her BE from Government Engineering College, Raipur, and presently it is known as National Institute of Technology, Raipur, NIT Raipur. And she did her post-graduation from Guru Ghazidas University. At present, it is called as Central University, Bilaspur. And she did a PhD from IIT Kharagpur, West Bengal. So her major areas of research interests include application of computational fluid dynamics, CFD, biofuel for IC engines, biofuels for engines, etc. She has published more than 60 uh, international papers in reputed international journals, and she has authored 4 books also. And Dr. Sinha, Madam, she received various awards such as Young Scientist Award, Rula Award, etc. She is an editorial board member of HBRP publication from May 19, 2018. So this is about the introduction about today's speaker. So for this session 1 on alternate fuels. Now I hand over this session to Madam. Yes, Madam, please you can take. Yes. Start. Yes, I request Sinha Madam to take the session. Please, Madam. Hello. 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 So make a problem. नहीं आ रहा है उसमें मेरा आवाज भी नहीं हेलो सिन्हा मैडम One minute, sir. Now madam is coming. वो ठीक है। हाँ हाँ, इन लोग भी रेस्पॉन्ड, हमारा भी नहीं जा रहा है क्या? म्यूट करो ना, अनम्यूट करके। हाँ अभी बोल दिए ना? बोले बोले फिर से बोले सर। सर अब
Now voice is coming, sir. Hello. Hello.
Yes, madam. Yes, madam.
Is coming now. Okay, sir.
Now voice is coming, madam.
This. Okay, sir. I'll just share my screen. Sir, but sharing is not visible, sir.
now you rejoin, now we have to give the sharing permission to you. So 1 minute, madam. Actually, your name now we are not able to identify your. 1 minute.
It is yes only, sir.
Yes, sir. Yes only ना?
Yeah.
फिर ये वाला, ये तो आ रहा है। Okay, madam. Now
Just
you
share
can
my
share the screen.
screen, sir.
Now you can share the screen, madam. Now, we have made you the organizer. Okay, please.
It is coming or not?
Huh?
Sir, you are viewing my screen.
No, sir. No, madam. No, madam. We are not able to view your screen. अच्छा SS dismiss. S कहाँ है सर?
No, that screen sharing is not coming, sir.
जान जाने इसमें आ रहा है. Actually, we are unable to find out your name, madam. That is the biggest problem for us. And I don't know by which name you have joined in this meeting. So that is the problem, na. So now S is not visible now.
Who is talking
I'm in a
mode so
position to
that
see people.
one suggestion,
Huh?
Dr. Rao,
Yeah.
See, I'm connected.
Yes, sir.
if you put
Yes,
this
sir.
view who is talking mode, when she speaks, professor speaks, you will get a name, full name, so that you can easily identify. That is the one way.
Yeah. Yes, madam. Now you can speak, madam. Yeah, yeah, that is true. But that trying. Please, madam. Please speak.
Pardon, sir? Are you in a position to see my
I am.
screen, sir? You just tell me.
Is
No, no,
yes,
no, madam. We are not in a position.
Screen
First,
is
we have.
visible or not?
Screen is not visible, madam. 1 minute, madam.
Waiting for name, it is writing. Where I should write my name?
Actually,
Enter your message, I'm writing my
wait,
name.
waiting for name. It is coming. Huh?
See, you
कहाँ पे
just
है?
check. I have written my name. Shobha Lata Sinha at 12:30.
अच्छा शोभलता सिन्हा
Are you
130.
writing it, sir? Yeah, yeah.
Waiting for name.
Pardon, sir?
ये शेयरिंग हुआ है ये इज प्रेजेंटिंग. Madam, can you edit your name, madam?
I wrote simply my name, Shobha Lata Sinha, because the edit part is not
I will-
visible
I
from
will
my
check.
end, sir. Edit is not
Sir, you
visible,
can
sir.
check name of madam. Sir, you can check name of madam by Abhinav Sinha. I think madam have login with the name Abhinav Sinha.
SL Sinha, my email ID is slsinha.mac@nitrr.ac.in.
When you are talking here, huh? Abhinav Sinha.
Yes, yes, Abhinav Sinha is the computer's login name. Yeah,
Yeah,
Abhinav
yeah.
Sinha.
That is showing here.
It's actually my computer's login, Abhinav Sinha is coming. Yeah.
Okay. It is identified
He's my
now.
nephew. Actually, his system, he actually setting he's done, so he wrote his name.
बना लिया आपने? हो गया ना?
I tried with both the system. I have the new computer also, old computer also. With both the system, camera is not working. I could not understand what is
Okay,
what is
no
the problem
problem,
with the
madam.
setting. Okay. You with Abhinav Sinha, you just check.
Yeah. Now you can share.
Okay.
Now, yeah, it is visible, ma'am. Hmm.
This
madam.
conference will now
Yes,
be
yes,
recorded.
So, good afternoon, all. I welcome you in my lecture. The topic is alternative fuels for internal combustion engine. This topic is very useful for the current era. You can just see.
लगा के रखिए, डिस्टरबेंस होगा तो समझ में नहीं आएगा.
Okay. So if you look to the picture that what is the world's primary energy consumption. So this is the just means data because we are using about coal 28%, hydroelectric 6%, nuclear energy 6%, oil 37% and the natural gas 23%. So here I am finding oil is being the highest primary energy source. So our efforts should move towards the development of new fuel for means that will be in liquid form that will be easy for us to handle. Now coming to the primary energy and fossil fuels, this is the data projection up to 2030. You can see that our energy demand is increasing. If you see the coal, 1407 million tons oil equivalent to 3601 it goes. So all the energy it is means increasing. So there is the demand always, and we had to cope up with that. So because of that, there is a need. Now the question is that if we go with the alternative fuel or any kind of fuel, the principal quality requirement of automobiles fuels are combustion quality, high heat of combustion, high volumetric energy content, low temperature performance, high temperature performance, oxidation stability, then deposit formation control and the material compatibility and the flow characteristics of the fuel is very important. Now these things are required just to get the better ignition and combustion quality and will get the more power output from the engine. Now coming to the background part, if you see that because of the increasing motorization of the world, this has led to a steep rise in the demand and the petroleum resources are actually finite. The highly concentrated in certain region, especially in the Gulf country, you will find more. And this is the source of environmental pollution also. And we require basically high fuel quality. These are actually the our requirement. Most of the fuel it is means if you will see that it is used in industry, it is used in transportation sector and other field also, but the transportation sector consumes 65% of the total petroleum products supplying in India. The transportation sector contributes about one third of CO2 emission, one third of NOx emission, nearly 77% of CO emission, around 45% of particulate matter. This is the pollution part which is coming because of the transportation sector only. So what to do to reduce our reliance on the petroleum based fuels? We'll go for the alternative fuels. Alternative fuel means the fuel that is for use in motor vehicles to deliver direct propulsion that should less damage the environment than the conventional fuels, and it should be prescribed by regulation including without limiting the generality of the foregoing ethanol, methanol, propane gas, natural gas, hydrogen, electricity, whatever the alternative we are using. Now the future gasoline fuel quality requirement, because the norms are becoming very strict, so our requirement will be the octane number should be greater than 95. This octane number actually the measure of resistance of fuel to knock, and we want aromatic olefins and sulfur to 0 because we don't want this component aromatic olefins sulfur. Aromatic means the unsaturated hydrocarbon. Olefins means this is also unsaturated, but aromatic means it will be cyclic, and sulfur is actually nuisance for the fuel. Now coming to the future diesel fuel requirement, the cetane number must be greater than 55. Cetane number shows actually the ignition quality of the diesel fuel. Here also we don't want aromatic and the sulfur. Now alternative fuels for IC engine, that what we have worked so far, that for the spark ignition engines we can use CNG, LPG, ethanol, hydrogen, and for compression ignition engine we require GTL, that is gas to liquid fuels, which is prepared by Fischer-Tropsch method, and this is called Fischer-Tropsch diesel also. And after that the dimethyl ether DME and the biodiesel. These are actually alternative fuels for IC engine. Now coming to the overview of alternative fuels for IC engine. Currently we are using CNG, LPG, ethanol, and the future fuels are biodiesel, fisher top diesel, DME, GTL fuels, and butanol. Now, here in this presentation, I shall be discussing about the use of methanol, ethanol, alcohol fuels, natural gas, compressed or liquefied, dimethyl ether, liquefied petroleum gas, that is LPG, hydrogen, biodiesel, and electricity. So, electricity means we are using either batteries operated cars or fuel cells. So, these are the fuels, alternative fuels I am discussing here. Now, coming to the methanol, methanol is actually the first member of the alcohol group, and this is the primary alternative methanol fuel being used is as M85. M85 means it is made of 85% methanol and 15% gasoline. In the future, neat methanol means M100 without adding gasoline may also be used. And how it is produced means you have to just buy a synthesis gas, you can get it, which is reacted in the presence of a catalyst. And methanol can also be produced from non-petroleum feedstocks such as coal and biomass. If we see, check the environmental characteristics, emissions from M85 vehicles are slightly lower than in gasoline powered vehicles. Smoke forming emissions are generally 30 to 50% lower. NOx and hydrocarbons emissions from M85 vehicles are similar to slightly lower. However, CO emissions are usually equal or slightly higher than in gasoline vehicles. Now, the main advantage is high octane and performance characteristics. Only minor modifications are needed to allow gasoline engines to use methanol, and there is a significant reduction of reactive emissions when using M85. These are the plus point. Now, if we go towards the second member of the alcohol group, that is ethanol, so it is very cheap, non-petroleum based fuel. As like methanol, we are using E85. E85 is the primary ethanol alternative fuel. Here 85% ethyl alcohol will be there, and rest 15% will be ethanol. So use of ethanol in vehicles is not a new innovation. In the 1880s, Henry Ford built one of the first automobiles to run on the ethanol. Now, it can be produced by fermentation of vegetables and plant materials in India. Its main source is molasses, a byproduct of sugarcane, and it is done in 3 stages: extraction of juice from sugarcane, fermentation of the juice, and the distillation. That you can see in the further slide also. As far as the environmental characteristics, you will find 30 to 50% less smoke forming emissions you will find as comparison to gasoline vehicles, and air toxics are also reduced by about 50% when compared to gasoline. As with all internal combustion engines, vehicles using ethanol emit minor amounts of aldehydes, and this is resolved by installing advanced catalytic converters on the vehicles. Now, major problem with ethanol is the corrosion. This problem you just check it out, because ethanol driven vehicles require lines, hoses, and valves to be resistant to the corrosion that alcohol can induce. The alcohol corrodes lead plated fuel tanks, magnesium, copper, lead, zinc, and aluminum parts, and some synthetic gaskets. So this is actually damaging because it is corroding this part. So we should be very careful about this. Now, coming to the carbon credit, you can see whatever means crop you are getting for the production of ethanol. That is, here I am showing the this maize. You can see this will be finely ground, and then the sugar component will be separated, and after that there will be the distillation, and we will take the ethanol. And ethanol will be used as fuel in the vehicle, and vehicle will emit carbon dioxide, and this carbon dioxide is absorbed by the crop, which is used for producing the alcohol. So there is no additional burden on the atmosphere as far as the carbon credit is concerned. Okay. Now coming to the next generation biomass and soft masses, you can make ethanol using corn stover, rice straw, switch grasses, and using this enzymatic saccharification, you can get C6, C5 mixed sugars, glucose, and xylose. And by microbial conversion, you can refine it, you can get the bioethanol. And this bioethanol you can use in the vehicle. So you have the options available. And here I am showing you the example of bioethanol. Focus is a flexible fuel vehicle. This car is actually 1 liters, 1.8 liters engine, it produces 70% less carbon dioxide than its petrol equivalent. It develops 123 bhp, and fuel E85 is actually used here. 85% ethanol and 15% petrol. Now we'll talk about the key features of alcohol as motor fuel. As an engineer, we have to see the alcohol, whether what advantage we can get and how we can manage it. So alcohols are a preferred alternative for SI engines only due to their high octane number. The octane number is really attracting us. A higher engine compression ratio could be used to obtain a higher engine thermal efficiency. The Cetane number of methanol and ethanol are close to 5 and 8. Direct injection, so if the Cetane number is less, then we can use this as the substitute for petrol engine, not the diesel engine. Direct injection alcohol engine prototypes operating similar to diesel or CI engines have also been developed using either a positive source of ignition or high dose of ignition quality improvers. Alcohols are not easily miscible in the diesel fuel. So to prepare a alcohol diesel blend, high amount of emulsifiers or solubilizers are used. Okay, so by this way, so you can see alcohols are not easily miscible in the diesel fuel. To prepare a alcohol diesel blends, high amount of emulsifiers or stabilizers are required. Now coming to the next feature, heating value of ethanol is approximately 60% and that of ethanol is only 45% of gasoline. This is actually the thing to decide. If you have the option gasoline, then you can go with the gasoline. But here, as far as the heating value is there, we are lagging because the alcohol is having less heating value. Now, stoichiometric air fuel ratio due to presence of oxygen in the molecule is much lower than the gasoline. The volumetric energy content of stoichiometric mixture of alcohols and gasoline, however, are not very different. Thus, engine specific power output that may be obtained with alcohols and gasoline is nearly the same. The latent heat of vaporization of methanol and ethanol is nearly 4 and 2.7 times respectively compared to gasoline. So cold starting performance with neat diesel is therefore so poor compared to gasoline. So here this problem will always be there because the latent heat of vaporization of methanol is 4 and 2.7 times respectively compared to gasoline. So in the cold climate, it will be somewhat difficulty, and the flames of heat alcohols in air are not easily visible to the naked eye. Hence, 15% gasoline is mixed to alcohol for making the flame visible in case of an accidental fire. Because this flame color, the color of flame is actually it is colorless. So we need to add 15% of gasoline, but in future they can make some arrangement so that it will be visible. Now, in the coming to the investigations, it is already carried out with alcohols and as an engine fuel, and many scientists are still working. So here they are finding that the emissions with low-level alcohol blends as well as with neat alcohols has been studied, and CO and NOx emissions shows no clear trend through lower flame temperatures with alcohol may result in lower NOx emissions. With neat diesel operation, as the emissions of most of the volatile organic compounds in the exhaust would consist of alcohol or aldehydes only. The photochemical activity and the ozone forming potential is lower with alcohol fuel operation. My voice is clear now, sir? Hello?
Yes, clear.
Okay. I'm moving.
Yes, madam, continue.
Sir, my voice is clear? I'm audible? Hello?
Yeah.
I'm audible,
Yes,
sir?
madam.
Yes,
Okay.
clear.
Yes,
So,
yes, you are audible.
So I am talking about the advantages and disadvantages of alcohol motor fuel in comparison to gasoline and diesel. If we see the parameter, the flame temperature as the performance temperature, we find flame temperature lower as comparison to gasoline and diesel, and the advantage will be potentially lower NOx emission and lower heat losses will be there. because the NOx emission we get at the higher flame temperature. Now, as far as the vapor pressure is considered, we are getting lower vapor pressure, and because of the lower vapor pressure, there will be cold starting and warm-up performance, higher unburned fuel emissions during starting or warm-up phase. As far as the particulate matter emissions, again, and because of that, it is clean burning characteristics, and even with the, it is lower than the gasoline engines. Air toxic emissions like maybe NOx, SOx, all those things. So it is lower, and the lower benzene and 1,3-butadiene emissions you will find. As far as the CO and NOx emission, it is no definite trend is observed, so no advantage over petroleum has been noted. Aldehyde emissions are higher here, and this formaldehyde and acetaldehyde emissions are higher. So you can see the nature of sources, especially of ethanol. So sources are widespread around the world, hence better energy security and lower CO2 emissions are found. So this is in general, if you compare the performance of alcohol as comparison to gasoline and diesel. Now coming to the next fuel, natural gas, CNG and LNG. So first, what basically the natural gas is, it is nothing but it is a mixture of hydrocarbons, mainly methane. It can be stored on a vehicle either in a compressed gaseous state or in a liquefied state. If you are storing it in a liquefied state, it will be named as LNG, that is liquefied natural gas. And if you are compressing it and then storing it, then it will be compressed natural gas, that is CNG. The natural gas is primarily extracted from gas wells or in conjunction with crude oil production. It can also be produced as a byproduct of landfill operations. Environmental characteristics, if you will see, natural gas has low CO emissions, low particulate matter, emissions, volatile organic compounds. Per unit of energy, natural gas contains less carbon than any other fossil fuel, leading to lower CO2 emissions per vehicle mile traveled. So this is about the environmental characteristics. Now, if you see the typical combustion of natural gas from two different sources, you can find this is the two wells they have taken. So in case of natural gas one, the methane is the main constituent. It is here 94.8, methane 2.9, propane 0.8, C4 and higher 0.2, CO2 is 0.1 and nitrogen is 1.8. In other setup, if you take the natural gas from other various sources, so there will be some slight difference in the proportion. So I'm just showing you here two sources which is giving you the natural gas. Now coming to the see the natural gas engine. Natural gas liquefiers actually natural gas liquefies at minus 161 degrees centigrade at atmospheric pressure. So to use this LPG as automatic fuel, cryogenic systems are required. And therefore, natural gas is stored on board high pressure cylinder at pressure of 200 to 300 bars as CNG. And storage of natural gas at high pressure on board provides an acceptable range of vehicle operation. Now, high engine quality of natural gas makes a fuel that is better suited for SI engines, start ignition engines, and these are the engines where we are using. The two types of natural gas engines have been developed. One is the fuel operation. There actually the conventional gasoline vehicles are converted to operate either on gasoline or on the natural gas. And another engine is known as dedicated NG operation. So this vehicle operating only on the natural gas using a spark ignition system. And the third one is the dual fuel CI engine operation. Here, natural gas usually is carbureted or induced along with intake air and gaseous fuel ignited by diesel injection spray. The amount of diesel used may be as low as 10%. So this is actually dual fuel operation. And as natural gas is very high number, dedicated natural gas engines can be built with a high compression ratio of around 11:1, which results in significant improvement in fuel efficiency and lower carbon dioxide emissions. Now, the lean burn spark ignited high compression ratio heavy duty engines can be built to give very low particulate emissions compared to diesel engines and a high energy efficiency similar to IDI engines. The stoichiometric SI engines can utilize three-way catalysts and therefore it provides the greatest emission reduction potential. So this is all about the. Now, if we see the emissions and performance of natural gas heavy-duty engine with three-way converter, European transient test cycles, you can see here that this light-duty SI natural gas engines runs at stoichiometric condition and uses three-way catalysis with natural gas mixture enrichment during cold starting, which is needed with gasoline operation is not required as the fuel is already in gas phase. As with natural gas operation, lower unburned fuel emissions during cold starting and warm up phase are obtained. Similarly, a very little mixture and enrichment is necessary during warm up and transient engine operation. CO emissions are also lower. So with this, with the use of electronic engine and fuel management and emission control technology, natural gas vehicles complying with US Tier 2 and it can cover more emissions compared to gasoline vehicles. Emission
There is
results
a
for two
problem,
vehicles
ma'am.
operating on gasoline and natural gas vehicles are completely stable. Now you can see this is NG engine, this is NG limit. This on CO is more, other components are very less. So by this way, these CNG and LNG gases engines are better. Now, as far as the control and safety are concerned, the control system, maybe the mechanical system, you can see there you need to control the refueling system and the computer controlled accounting for all the amount of fuel dispensed to the vehicles and billing functions. Now, as far as the leak detection is concerned, the methane detectors must be placed above ground level at points where religious gas is likely to pass. And if you want to suppress the fire, so this is required. And dry chemicals using infrared detectors are installed and work as effectively on natural gas fires as gasoline fires. And for lightning protection, for CNG refueling system located outdoor to protect from fire hazards. Advantages, it's very cheap. It's very cheap. It's engine friendly. It's safe, and there is lot of it. Its availability in India. It's clean, easy to trap, and odorless. And as far as disadvantage, the storage cylinder takes a lot of space. CNG gas stations are not widely available in India. These are the disadvantages. Coming to the next fuel, that is liquefied petroleum gas, LPG. So what is LPG? Actually, it consists of various hydrocarbons, mainly propane, propylene, butane, butylene, and various mixtures. And the main constituent in most of the cases is propane. And LPG is nothing but it is a byproduct of natural gas processing and petroleum refining. As far as the environmental characteristics are concerned, the LPG run vehicles have lower emissions of reactive hydrocarbons, about one-third less, NOx 20% less, and CO 60% less than the gasoline. General characteristics we see for the use of most LPG vehicles operate systems or operate either on gasoline or LPG. It is important as the number of LPG one drawback with a bifuel system is that the engine is neither optimized on LPG nor on gasoline, and better cold start and warm up characteristics due to its gaseous system compared to gasoline, hence lower hydrocarbon emission you will find. Now, FC emissions from LPG vehicles have significantly lower potential of smoke formation compared to gasoline and diesel fuels. So, if you see the PM emission, it is very negligible compared to diesel. Small reductions in CO compared to gasoline, as no enrichment of mixtures during warm up or acceleration is required. No significant difference in NOx emissions. Variation in propane butane ratio in LPG poses problem as the octane number of the two main constituents propane. This is the research octane number is 112, and for butane it is 94. It is quite different. And for biofuel vehicle, specific technological development may be necessary to ensure compliance with the stringent emission standards. So this is general characteristics. If we see the advantage for this, cost is 50% of petrol with 90% of its mileage, so it is advantageous. It has a higher octane number and burns more efficiently. LPG has many of the storage and transportation advantages of liquids along with the fuel advantages of gases, and it saves on the maintenance costs. Next fuel, I'm considering dimethyl ether, that is DME. DME is actually the simplest ether consisting of two methyl groups bonded to a central oxygen atom as compressed by its chemical. You can see this is the CH3. Here, this is oxygen is with the red one, and this is the hydrogen. Black one is carbon. So this is the dimethyl ether. Just I've shown you the structure, and this can be produced from natural gas, providing an alternative way of its utilization in competition to such technologies as Fischer-Tropsch synthetic fuels, as well as from other carbon-containing feedstocks, including coal and various types of biomass. DME has replaced CFC gases as their environmental value and safe aerosol propellant, which is one of its major current applications. Potential future uses of DME include an alternative automotive fuel, a substitute for other fuels in power generation, and in the household, and a source of hydrogen for fuel cells. If you see the this DME, you can see the various properties like density, viscosity, lubricity, etc. And you compare it, then the entire fuel system must be redesigned for the engine. So while DME could reduce emissions compared to diesel fuel, the emission benefits comes at a price of a specific level of complexity of the fuel storage and injection system, including the need to carry a pressurized fuel tank on board the vehicle. Furthermore, DME fuel lacks an established supply and fueling infrastructure. Therefore, the DME fuel is more likely to be used in certain applications rather than provide a wide scale alternative to liquid diesel fuel. In an alternative utilization method, DME can be blended with propane for use in spark ignited LPG engine, and DME LPG blends have been used in China, a country with a large DME production base, where DME has also been blended into city gas supplied for residential use. Now there are the OME fuels also. OME fuels is nothing but it is polyoxymethylene dimethyl ether, abbreviated as OME or PODE or POMDME. It is a class of DME derivative that includes several oxymethylene or OCH2 group in the molecule with a chemical formula CH3OCH2N OCH3. And these compounds with N of 3 or 4 were tested as diesel engine fuels. Like DME, OME fuels are characterized by soot-free combustion. So this is actually the good thing that you won't get any soot in the engine. So this is the representation of OME3 fuel. So here you can see due to their higher molecular mass and boiling point, OME compounds may also be blended with diesel fuel, and blends of 5 to 10% OME in diesel were investigated in engine studies. Since OME compounds are excellent solvents, they are not necessarily compatible with the elastomers and other materials used in diesel engine. So if the elastomers are there, then you must be careful. Now, if you see the properties, C10 number is greater than 56 for this DME, and the lower heating value is 28.6 megajoules per kg, density is 0.661, and there is no sulfur. Now, basic disadvantage is that the viscosity of DME is lower than that of diesel oil by a factor of about 20. So this can cause higher rates of leakage through a small clearance because it's very thin layer. So it can be leaked out. So it can be looked through a small clearance such as pump plungers and injection nozzles. So this has to be taken into consideration. And this is actually the process how we convert the GTL, that means the coal or biogas after gasification. This is in gas, and this gas will be then after further synthesis, it will be converted to the liquid fuel, that is methanol, DME, diesel, naphtha or electricity. Now coming to the next fuel, that is hydrogen. You are very much aware with the hydrogen, and what is the hydrogen? It is the lightest element. It is most abundant element in the universe. It's not a direct energy source. It can be obtained by means of solar energy, and nowadays 95% is obtained from the fossil fuels also. So there are the various methods for producing the hydrogen, and you can including natural gas, water, methanol, etc. So two methods of generally used to produce hydrogen are electrolysis of water. You just supply current to the water on the anode and cathode, you will get hydrogen or oxygen collected. So you can collect the hydrogen from one end and the oxygen from another end. Now synthesis gas production from steam reforming or partial oxidation, you just see methane will react with water and it will give you carbon monoxide and hydrogen. And CO plus H2O, again it will give you the carbon dioxide plus hydrogen. This is actually partial reaction. You can add it and the CO will be cancelled out. So basically CH4 plus H2O will be CO2 plus H2. And photoelectrolysis uses sunlight and catalyst to split water. So these are the methods. So first two methods are the third method is nothing but only instead of electrolysis, it is photoelectrolysis. Now coming to the biomass also you can produce it. So biomass gasification uses selected microbes to break down a variety of biomass feedstocks into hydrogen. Pyrolysis can also be done. Then the photobiologic production uses sunlight and the biological organisms to split water. And hydrogen production on board the vehicle, you can thus use the methanol. Methanol will burn and it will give you CO2 and hydrogen. And using ethanol also, it will react with water and it will give you CO2 plus hydrogen. Now coming to the environmental characteristics, when it is combusted, only water is produced, so there will be no emission. When burned in an IC engine, a small amount of nitrogen oxides and a small amount of unburnt hydrocarbons and carbon monoxides are also produced due to the use of engine lubricants. And the atmospheric oxygen is there, so from there it is taking the nitrogen of that part, so it get oxidized. Now coming to the smoke, you can see that the CO, HC, PM smoke all goes to zero. So there is all advantage only, there no emission. Advantages will be, you can see abundant element in the universe, high efficiency, low working temperature and pressure. Hydrogen air mixture burns nearly 10 times faster than gasoline air mixture. Hydrogen has a high self-ignition temperature but requires very little energy to ignite it. Clean exhaust produces no CO2. As a fuel, it is very efficient as there are no losses associated with throttling, and it's a silent functioning. Regarding disadvantage, there is a danger of backfire. This is very alarming. And induction ignition, though low in exhaust, it produces toxic NOx. It is difficult to handle and store. It is requiring high capital and running cost. It is not a primary source. Obtaining pure hydrogen is really expensive. High storage and supply cost, high weights of fuel cells for current prototypes, and high energetic expenses to liquefy the hydrogen. These are the disadvantages. If you see the comparison of hydrogen storage methods, like suppose gasoline, this is the first data shows for the gasoline. If you have the liquid hydrogen, that the energy content stored in megajoules is 600, fuel mass 5, tank mass 19, total fuel mass 24, and the volume in liters 178. If you are storing hydrogen in form of hydride, then it will be 600 is energy, fuel mass will be 5, tank mass will be 550, total fuel system mass will be 555, and volume will be 190. And if you are using compressed one, the energy will be same, fuel mass will be 5, tank mass will be 85, total fuel system will be 90, and volume will be 227. So storing is really difficult thing for the this hydrogen. Now coming to the combustion characteristics of hydrogen and impact on emission, you can see hydrogen octane rating is 106 RON, making it more suitable for spark ignited engines. Laminar flame speed of hydrogen is 3 meters per second, about 10 times that of gasoline and methane. So you can understand the speed of combustion. Now hydrogen has very wide flammability limits ranging from 5 to 75% by volume, which may lead to pre-ignition and backfiring problems. Its adiabatic flame temperature is also higher by about 110 degrees centigrade compared to gasoline. If inducted alone with intact air, the volume of hydrogen is nearly 30% of the stoichiometric air, decreasing maximum engine power. So hydrogen on combustion produces water and there are no emissions of carbon containing pollutants such as hydrocarbons, CO and CO2 and air toxics. Trace amounts of hydrocarbons, CO and CO2, however, may be emitted as a result of combustion of lubricating oil leaking into the engine cylinder. Now, NOx is the only pollutant of concern from hydrogen engines. very low NOx emissions can be obtained with extremely lean engine operation and or injection of water intake manifold or exhaust gas recirculation, which in this case consists primarily of copper vapors. NOx emissions of 0.013 gram per kilometer have been obtained, which are about 1/10 of the US Tier 2 regulations. And hydrogen fueled engines produce almost no CO2 and its global warming potential is insignificant. So limitations means if you are considering then the hydrogen fueled IC engines, however, are not considered a long-term operation when compared to fuel cell. Hydrogen fuel cell vehicles are expected to have more commercial potential in the long run. Though it is believed that the significant production volume for customers will be available until the 2070 to 2020 time frame. For 2020, only how many months left? We are it is September, so October, November, December, 3 months left. So we could not complete the target. Now coming to the biodiesel, various speakers will speak about biodiesel, so I will be taking less time for the biodiesel. So before starting this, first I'll tell you that what is biodiesel. It is a fuel made primarily from the oils of vegetable seeds and fats. Although it can be used as a straight replacement to diesel, the blend of biodiesel to diesel can be as low as 20% biodiesel and 80% diesel. The method of producing is it can be produced through a transesterification process forming fatty esters. One of the byproducts of production is glycerol, which can be sold as an independent product also. Now this here I am showing the esterification ratio of vegetable oils and fats. This is the triglyceride, this is the oil. It is reacting with the methanol in the presence of catalyst. Catalyst may be KOH or NOH you will take, and you will get the methyl esters and glycerol. This will be glycerol will be separated out and sold it to the market. And this methyl ester is actually the biodiesel, and that is used as a fuel in the CI engine. Now, here I am talking about the properties of biodiesel derived from some vegetable oils. You can use any kind of vegetable oil, and you can just do the characterization and you can find out all the properties. So here I am showing the rapeseed methyl ester and the jatropha methyl ester. So this is the molecular weight is about 300, here 293, hydrogen carbon ratio 0.15, here 0.157, oxygen content 9 to 11, here it is 10 to 10.9, relative density 0.882, this is 0.88, kinematic viscosity 4.57, it is 4.4, cetane number is 51.6, it is 57.1, lower heat combustion it is 37.7, for jatropha it is 38.45, and sulfur content is almost negligible, it is less than 0.002, here it is 0.020 for jatropha. So these properties, if you will take any kind of other, maybe you can take Karanj, you can take Ambadi, you can any kind of seed you can take. So as far as the carbon credit is concerned, again it is just like alcohol only, that whatever the carbon dioxide it is taking from the atmosphere for the production of the for the development of oil seed, that will be actually used. This oil will be extracted and the biodiesel will be prepared, and then it will be used in the vehicle. So whatever exhaust is coming, that is actually taken as the input. So though no additional burden of CO2 in the atmosphere. This CO2 is very important because this is also responsible for the global warming. So we should not add extra CO2 in the atmosphere. So we should be try to use our biodiesel or the biofuel so that we can make our atmosphere clean and the global warming that temperature can also be reduced. Now these are the seeds I am showing you of the Hibiscus subdarifa. This is the neophil, and that we have used in our garden. We developed this ambadi. It is called ambadi also. In the biological term, it is Hibiscus subdarifa, and the seeds are shown here. And these seeds are actually the oil we are taken out, and after that prepared biodiesel in our lab. This is the glycerol we have separated out. This is the biodiesel, and we have used it, and it is working very well. Now, as far as the environmental characteristics are concerned, the biodiesel has no aromatic content and only trace amounts of sulfur in vehicle tests. In vehicle tests, it has lower emissions of carbon monoxide, soot, and polycyclic aromatic hydrocarbons than conventional diesel. So, with adjustments in the injection engine timing, it is possible to reduce the NOx emissions also. With the biofuel, you will find there will be more NOx because it is oxygenated fuel. Oxygen is there. Now, as far as the advantages are concerned, the low emissions, it is biodegradable and non-toxic, low cost, high CTN number, and high lubricity. Regarding emission, you can find already I have told you that the CO, HC, PM is reduced, but NOx is more. Okay, so because of that, we are using with the current engine, means whatever engine is designed for the diesel engine, there we are using up to 20% blend of biodiesel we are using, and engine is working very well as far as the thermal efficiency is concerned or the emission will be concerned. It is working very well. So these are the features of emission. If you use the use of biodiesel results in reduction of CO, HCPM, but slight increase in NOx. A reduction in CO emission is attributed to the presence of oxygen in the fuel. Slight increase in NOx emission results perhaps due to advancement of dynamic injection timing with biodiesel, and lower SOF, that is soluble organic fraction with biodiesel, and advanced injection timing also result in lower PM emissions. Volumetric fuel consumption with biodiesel is higher than diesel fuel due to its lower heating value. An increase of 10 to 11% in fuel consumption compared to diesel may be expected when comparing their heating value. Heating value is less than the diesel. So an increase in volumetric fuel consumption by 0.9 to 2.1% with 20% blend has been obtained. This is the picture of the percent biodiesel. If like suppose you are adding 20% or the 40% or 60% or 80% or 100%. So this is the trend that the NOx is increasing and this PM, CO and SC is showing the downtrend. Now coming to the average reduction in emissions with use of biodiesel and 20% biodiesel blends compared to diesel. Like suppose you are running your engine with 100% biodiesel or you are running your engine with 20% biodiesel and 80% diesel. So you can see for hydrocarbon here it is minus 93%, here it is minus 30. So here 93% reduction in SC, here 30% reduction. For CO 50% reduction, for B20 case it is 20. For PM it is 30% reduction, it is 22% reduction. NOx it is 13, here 2. And this is PAH minus 80, minus 30, and sulfates minus 100, and it is minus 20%. So this is all about the biodiesel. Now I am moving with the electricity, that is batteries and the fuel cells. So electricity is nothing but it is a type of energy where mechanical power is derived directly from it, as opposed to other alternative fuels which release stored chemical energy through combustion to provide mechanical power. Electricity in vehicles is commonly provided by rechargeable batteries, but fuel cells are also being explored. Now, environmental characteristics, battery powered electric vehicles are almost zero emission vehicles. Fuel cell emissions using hydrogen as fuel are water vapor and the heat. This is the electric operated car. Now it is running on the road also. You have seen many cars are coming on the road. Now batteries are actually the storage tanks for electricity, and the quantity of potential power available from them is given by the battery rating determined by plate size, quantity of electrolytes, etc. And the fuel market, electricity fueling costs are quite, especially if all off-peak rates are taken advantage of it. However, the cost of electricity varies dependent on the country, location, type of generation, and time of use. So this is the issue. And next is I am considering taking the fuel cell. Fuel cells do not store energy. The battery stores the energy. Fuel cells do not store energy. In a state, chemical energy converted into electricity here. So an external source of hydrogen, for example, from natural gas, gasoline, or one of the alcohol fuels, and oxygen from air are fed to the fuel cell. The electrolyte fuel cells employ the electrochemical reaction between hydrogen and oxygen to generate electricity. Now you can see the fuel cell is a device that generates electricity. Every fuel cell has two electrodes called anode and cathode, and the reactions that produce electricity take place at the electrode. Every fuel cell has an electrolyte which carries electrically charged particles from one electrode to the other, and a catalyst which speeds the reaction of the electrode. And hydrogen is the basic fuel that we are taking, and it will require oxygen. One great appeal of fuel cell is that they generate electricity with very little pollution. Much of the hydrogen and oxygen used in generating electricity ultimately combine to form a harmless byproduct, namely water. And one detail of terminology, a single fuel cell generates a tiny amount of direct current, electricity, So in practice, many fuel cells are usually assembled into a stack, and cell or stack, the principles are the same. So here you can see the fuel cell. From this side, it is hydrogen is supplied. This is anode, this is cathode, and in between that, electrolyte is there. So this hydrogen will move on this side, reacts with water, and produce electricity. You just connect the wire from the electrode and the cathode and the anode, and you will get the electric power, and the water will be produced, and this water can be used for further maybe drinking purpose or for any other use. And this is the excess hydrogen which comes on this side, that will be used back for running this fuel cell. So I'll be showing you the different types of fuel cells here. First, I'm showing the alkali fuel cells. It operates on compressed hydrogen and oxygen. Here, they generally use a solution of potassium hydroxide. Here, the potassium hydroxide solution is there in water as their electrolyte, and efficiency is about 70%. And operating temperature, you are getting 100 to 200 degrees centigrade. So cell output ranges from 300 watt to 5 kilowatt. Alkali cells were used in Apollo spacecraft to provide both electricity and drinking water. They require pure hydrogen fuel. However, their platinum electrode catalysts are expensive, and like any container filled with liquid, they can leak. So this is the picture. This is the anode and this is the cathode. Here the electrolyte is there. Hydrogen will be supplied from this end. Oxygen will be supplied from this end. So this will be in the electrolyte. There will be reaction and the water will be formed, and this water will come out. Now coming to the next one, that is the molten carbonate fuel cell. This use high temperature compounds of salt like sodium or magnesium carbonates here. So the CO3 ion will come out of it. Efficiency ranges from 60 to 80%, and operating temperature is about 650 degrees centigrade. This is remarkable. Units with output up to 2 megawatt have been constructed, and design adjust for unit up to 100 megawatt. The high temperature limits damage from carbon monoxide, poisoning of the cell, and waste heat can be recycled to make additional electricity. Their nickel electrode catalysts are inexpensive compared to the platinum used in other cells, but the high temperature also limits the materials and safe uses of this molten carbonate fuel cell. They would probably be too hot for home use. Also, carbonate ions from the electrolyte are used up in the reactions, making it necessary to inject carbon dioxide to compensate here. And next is the phosphoric acid fuel cell. Here, phosphoric acid will be used as the electrolyte. Efficiency ranges from 40 to 80%, and operating temperature 150 to 200 degrees centigrade. Existing phosphoric acid cell have output up to 200 kilowatt, and 11 kilowatt units have been tested. And this tolerate a carbon monoxide concentration about 1.5%, which broadens the choice of fuels they can use. If gasoline is used, the sulfur must be removed, and platinum electrode catalysts are needed, and internal parts must be able to withstand the corrosive acid. Now coming to the proton exchange membrane type of fuel cell, it works with a polymer electrolyte. Here it will be the polymer electrolyte in the form of thin permeable sheet. Efficiency is 40 to 50%, and operating temperature about 80 degrees centigrade. This cell output generally range from 50 to 250 kilowatt, and the solid flexible electrolyte will not leak or crack, and these cells operate at a low enough temperature to make them suitable for homes and cars, but their fuels must be purified, and a platinum catalyst is used on both sides of the membranes. It is raising the cost. This platinum is actually costly. So depending upon your requirement and the efficiency and the temperature range, you can select any of the fuel cell. Next one is the solid oxide fuel cell. This uses a hard ceramic compound here of metal like calcium or zirconium oxides as electrolyte. Efficiency is about 60%, and you can get temperature up to 1000 degrees centigrade. So cells output is up to 100 kilowatt. As such, high temperatures, a reformer is not required to extract hydrogen from the fuel, and waste heat can be recycled to make additional electricity. However, the high temperature limits applications of SOFC units, and they tend to be rather large. While solid electrolyte cannot leak, they can crack because it is actually the ceramic compound. So leakage is not the problem with this type of fuel cell. Now, what problems need to be solved with the fuel cell? Because the size is becoming big, so we have to reduce the size and weight of all the components of a fuel cell power system to improve overall fuel efficiency. We have to reduce the cost of producing the fuel cell stacks. we should help fuel cells start faster and respond better to rapid changes in power requirement. Increase durability and reliability in extreme operating conditions and improve the processing systems that convert hydrocarbon fuels such as gasoline into hydrogen to the fuel cell. In conclusion, we can say that our dependency on energy is central to our economy and way of life. Economically, we need to utilize all these new and renewable types of fuels, as our supplies of many current fuels are very limited. So environmentally, burning fossil fuels has been greatly affecting and damaging our planet. So it is very important to compare all types of fuels in order to determine the best ones economically and environmentally, short term and long term. For this, we need to develop our alternative fuels and we should start using it also, so that our dependency will also reduce. With this, I thank you all for listening me patiently. Thank you. Thank you very much. Hello.
Yes, madam. Thank you, ma'am.
Thank you, sir. Thank you. Is there any doubt or question answer session?
Yeah. Now it is time.
If anybody is having doubt, they can ask.
Hello.
Regarding the material, they can use NPTEL website. They can use NPTEL website and many of the, I'll just show again the list of the references. Sorry. These are the list of the references. I have used this Ganeshan book,
Hello.
then the Krauss, and these are the web resources I am using. So if they can not go to all the sites, they can use this NPTEL, nptel.ac.in. That's the certificate one.
Madam, I have one doubt.
Yeah.
Yeah, this is Suresh from Karunya University, Coimbatore. As you mentioned that slide, biodiesel is a most useful in diesel engine. What is the reason biodiesel produce lower emission?
Biodiesel produce
Lower emission, what is the reason? Compared to other
no
fuel,
air emission. Yeah. Yes. I'm
biodiesel
coming to
produce
that.
low emission. What is the reason?
I'll just tell you that
And
this is
one more
the
thing,
reaction you are seeing. Yes, sir. This is actually the biodiesel. This is the methyl ester is biodiesel. So our biodiesel is having the oxygen built up there. Inside that there is the oxygen atom also. So when the fuel is burning, it is getting more oxygen. The each particle, each drop of the fuel, it is surrounded by the oxygen from the atmosphere also and from inbuilt oxygen also. So it is getting properly burned. When it is getting properly burned, there is, if some hydrogen is there, it will be converted to water. If carbon is there, it will be converted to carbon dioxide. Because of that, there is no emission. There is no harmful emission. But
only that is a reason to reduce biodiesel lower emission.
yes.
And one more
And
doubt.
another thing that,
Yeah, one more doubt. So there are different methods to produce biodiesel production. Why we are going to use for trans-esterification method?
Trans-esterification, see, this is actually the chemical part. You can do esterification also, you can do trans-esterification also. There are various methods. And after doing the various methods, you just
What
compare
are the various methods,
properties.
madam?
The
What
one
are
is
the various
esterification.
methods?
I'm telling you, esterification is other method, trans-esterification is other method, and besides this, there is other methods or there are more methods by which they are using getting the methyl esters. But when you will use the various method to get the methyl esters, you need to check the properties. So far, whatever the scientists have suggested, that after comparing the properties, they are finding this esterification method will be after esterification they are getting the properties.
Madam, just a minute, madam. Just a minute.
Yeah.
So whatever your method explaining is correct, but my question is compared to pyrolysis method or microemulsion method or direct method, why is trans esterification method is most important? What is the advantages?
Advantage is that you are using what you are using here, methyl alcohol, catalyst, you are taking KOH or NaOH. So these are easily available. If you are using the emulsifier, etc., that will be also costly and it is time consuming. So with trans-esterification process, there is no problem. Only thing that the time and the temperature is to be maintained properly, and nothing is there. And there is no setup. No more setup is required for this.
And so there are different.
In the lab itself,
Okay, sir. Sir, please
Yeah.
give others a chance also. Yes, anyone want to
Hello.
ask? Yeah, yeah.
yeah.
Ma'am, I'm Dr. Sudhi, Bangalore, ma'am. Please share the presentation slides, ma'am, to us.
Shall I
Hello.
ask questions or?
Yeah, you
Ma'am,
can ask.
can you please share this PPT slides, ma'am?
PPT slides, madam, actually, I have collected from various website.
Yeah.
Okay, ma'am.
I'm giving you the list of website because this distributing the website
Yeah, madam.
material
That
is
is
not
fine, madam.
allowed.
You please
Madam, I have
share
some
the
doubts regarding this.
list of
Slides are
websites and
showing
or else.
that websites also we need, ma'am.
One by one,
I have
will
some
ask one
doubt.
question.
Website.
Can you clarify?
Ma'am,
Okay.
ma'am, one more doubt, ma'am.
Yeah.
Ma'am,
Yes.
it is being told that biodiesel enough research has been taken place. Now there is no way for that is considering biodiesel as a diesel substitute. Is it right, ma'am?
Madam, your voice is breaking. Can you?
Shall I ask some doubts? Hello.
Yes, sir.
Are you audible?
Yes.
Yeah.
Yeah.
Nowadays we are using for BS6 norms. How does BS6 emission norms differ from BS4? What is the main difference?
This norm actually, the data I'm not means remembering presently, but in my next lecture I'll try to cover that.
Even
Data I'm
one
not
more
remembering.
question. Yeah, okay. Last question. So there are different emissions produced in terms of diesel engine, petrol engine, or whatever biodiesel also. Why it is NOx emission increase? What is the reason? How to control NOx emission? What are all the various methods to control NOx emission?
These are actually already you studied in IC engine, I think. See, why the NOx is coming? Actually, the source of nitrogen is two things. One is the fuel itself, and another is the atmospheric air. We are getting nitrogen from there. So when inside the engine, the burning combustion process is started. After that, what will happen? That at the peak of power is during the power stroke, the temperature is increased.
What
At
about
the
peak
time of
temperature?
combustion, the temperature will
Peak
become
temperature.
higher. Like so, if
how
you
to
will draw the
control,
TS
madam?
diagram,
How to
I'll tell
control
you.
NOx
I'm coming
emission?
to that.
Yeah.
See, I'm coming to that. When you will use this biofuel, because NOx is formed at the peak temperature. If you will get the peak temperature of the cycle more, then there will be more chances of NOx formation. So there is the way, either you can use the exhaust gas recirculation, just like part of the exhaust gas, you mix it with the inlet air. So what will happen, that the quantity of oxygen will get reduced and the peak temperature will get suppressed. This is one of the method. Another is that if you will inject water, then also the temperature will get increased. So these are the ways you can use it.
So
And
what
there are
about
other methods also.
yeah, EGR,
Pardon?
then catalytic converter. If suppose we are going to use
EGR for diesel engine, actually the diesel engine smoke is very dirty. So when you will use that
catalytic
10% or
converter,
5% of that, then when you will use that 10% or 5% of that, you need to pass it through the filter, and then you supply the inlet air and then run the engine.
And one more doubt is, madam, last doubt.
Hello.
As we mentioned in the PPT, advantages of biodiesel low cost, but generally, what do you call it? Disadvantage only will be covered for biodiesel is high cost. So how to
You
justify
tell me the
you're
slide
telling
number.
about
You
low
tell
cost
me
as
the slide.
biodiesel?
Just a minute. You tell me the slide
Your
number,
slide.
then I'll be in a position to.
Yeah, you
Pardon?
can go through biodiesel advantages. Biodiesel
This one.
advantages. Yeah, there you mentioned low cost.
Yeah.
What do you mean by
mentioned
low cost? Yeah.
low cost means this the seeds are cheaply available.
When compared to
Seeds are
diesel,
cheaply
it is high
available.
cost only.
These are not
This is the
the
main disadvantage.
This is not main disadvantage. India is highly populated area. Okay. So
Okay.
here you are
Okay.
getting the people also, they can even collect it, extract the oil, and you can convert this biodiesel, and you can make your own, make you
I mean, you're talking
self-sufficient.
about your area, not for general.
Not in general, how you are telling. Most of the people, see, these are the political issues. I don't want to comment any political thing. The people, many people are not working at all. For them, okay, if you will use it, then the cost will be reduced. And if you are not using it and you are thinking that labor will be paid very high and without working, then it will become higher cost. Otherwise, with the population, if you will distribute it, it will be okay.
Hello, madam.
Okay, madam.
And another
Thank you.
thing,
Thank you.
one thing I'll tell you,
And-
that because of the global warming, if means near the all the roads and the streets, if you will plant like karanj or this all bearing seeds near the roads, you will find the greenery also, and you will find more seeds also. Once you will get the seeds, you just find out oil and then convert this into the biodiesel. So this will open the employment avenue for the people also. Now see, because of this corona problem, many people are getting unemployed. So it's opening the new avenue for them. So they can do it. So when you will do it in the large scale, the cost will reduce. Presently, what is happening, we are developing it for the lab work only. So because of that, the cost is more. When you will do.
Okay, thank you, madam. Thank you. Thank you.
Ma'am, good afternoon, ma'am. Ma'am, good afternoon, ma'am. Good afternoon, ma'am.
Sir, meeting is ended, sir.
Hey,
Hello,
good
sir.
afternoon, ma'am.
Hello. Yes, madam, you can ask question.
Good afternoon, ma'am.
Yes,
Sir,
madam, you can
madam.
ask question.
Ma'am, what is the new and latest unresearched biodiesel source, ma'am?
Hello. Hello, ma'am. Sina, ma'am. Sina, ma'am. Hello.
Sir, meeting is ended, sir.
Yeah, meeting is ended, sir, almost all, but madam is now clearing the doubts now. So if you want to leave the meeting, you can leave, sir. Meeting is now ended. Thank you for attending. So we'll be meeting for the next session at 2 o'clock. So we will again gather in this app at 2 o'clock for next session. So next session.
Okay, sir. Okay, sir. Sir, madam
Sir,
has shown the
But
website
not
list
receiving
and
any feedback, sir.
sir.
that list
Not
we
receiving
want, sir.
feedback.
Madam has shown no website list.
Website list.
Last
Last slide.
website
Okay,
list
that I
and
will post it. That I will post it in the WhatsApp, sir.
Okay, no problem.
Okay,
Sir,
okay.
attendance,
Thank you. Is there is any
Attendance
attendance?
already
Thank
taken,
you.
sir. Attendance already taken, and I will also send you the attendance list also. You can cross verify, because some faculty members, they have admitted without their name, administrator, like that. So many names are there. So I request those faculty members, na, see, admin name is there, and without entering their CMD, so we can't understand their names, na. So how can we verify with our attendance? Na, it is difficult. So I request those people who have not entered their name. So for next session, you please enter your name so that we can count your attendance. Otherwise, it will be difficult for us to count your attendance. Okay. Okay, then fine. I think madam is left because of some meeting and all. I think he assumes. So anyway, so whatever the doubts you are having, we will try to clear in the next sessions. So yeah, we'll again meet at the next session. I will be sending you the ID through the WhatsApp, please. Okay then.